Okay, so here we go, questions 3 through 5. All right, so the first one says we got to figure out the molecule with only one double bond. So let's go ahead and draw out our molecules. So molecule A is going to be CO2. Now I know that CO2 is going to look something like this, right? And hopefully you know that structure. Maybe you haven't memorized it, but you can also figure it out by doing the Lewis dot structure and then just kind of figuring it out. The next one's going to be H2O. And again, I hope you guys know this one. It's pretty common. It's water. The next one is going to be CH4, which bonus points if you know this one and what it's called. You probably won't know until you take organic chemistry. But this one's actually called methane. So we can go ahead and draw it out here. It is only going to contain single bonds. Now, if I go and look at structure D, so I'll go down here now. Let's see, yeah. So for this one, I am going to have, it's going to look something like this. All right, and you would just do a Lewis dot structure to figure that out. But I'm going to cheat a little bit because I think you can kind of reason through and understand why that's the case. And then our last one is going to be this structure here. So phosphorus with 3 hydrogens. And sorry, hang on, I forgot to draw this one. Goes to there. All right, and this one's just going to be phosphorus with, again, the 3 hydrogens. And then, it's also helpful to kind of draw in the lone pairs. So for oxygen, I'll go ahead and draw in the 2 lone pairs here. Just 1 lone pair here. What else? Actually, hang on, I'm sorry. There's nothing here. Oops. No lone pairs there, right? Because we already have our double bonds, so we're good to go for that oxygen. Now for this phosphorus, remember that phosphorus can actually take up to 6 bonds, so we're going to need to have some extra lone pairs of electrons, right? So it's going to look something like that. All right, so now what I want to do is figure out, well, okay, sorry, first I kind of got ahead of myself. Let's look at the molecule with only 1 double bond. Well, that's going to be this one right here, answer choice D. So I'll go ahead and write that in that answer. The next one is the molecule with the largest dipole moment. So remember, a dipole moment is basically just where we have a very polar molecule, right? So I want to look for a polar molecule that is asymmetrical. So here, let me write that out here. So dipole moment. So I want it to be, we're going to say polar plus asymmetrical. All right, so out of all these molecules, which one is polar and asymmetrical? Well, this one is probably going to be polar. Well, how do I say this? It's not that it's necessarily polar, but that it has a polar molecule, right? Or molecules. Okay, so this one, it could be considered polar, right? Although it looks to me, let's see. Yeah, that one's probably going to be a little bit polar. But water is polar and it has oxygen. And we know that oxygen is a very, very electronegative atom, so much so that we're actually going to get partial positives on these hydrogens. And then we're also going to get, that delta minus, or the partial negative on the oxygen. So therefore, the one with the largest dipole moment is actually going to be oxygen, right? And again, sometimes they draw arrows from positive to negative or negative positive, but it doesn't really matter. Main thing is that because water has this bent structure, right, and it's polar, we're going to get that it has a large dipole moment. So number 4 is going to be water. So that's going to be answer choice B. And then the molecule that has trigonal pyramidal geometry. Let's figure out which one here has trigonal pyramidal geometry. So this one, I mean, it's a little bit trickier, right? Let's just kind of go through it. So CO2, this one's going to be linear, right? Because I have these 2 double bonds, not a lot of rotation. I know that water is going to have a bent orientation. I know that methane is going to have a tetrahedral orientation. Wait, is that right? Yes, it's going to be tetrahedral. And I know that this one right here, well, that one's also going to be linear. You can tell by kind of comparing it to CO2. So if these answer choices are all out, that only leaves me with answer choice E. And as you can see, this one will orient itself, based off of the repulsion of the lone pairs, so that we do get that trigonal pyramidal geometry. So therefore, the correct answer for 5 is going to be answer choice E. So we're going to have 3 is answer choice D, 4 is B, and 5 is E. And those are all the correct answers. If you guys have any questions, feel free to comment below, and I'll see you in the next video.